Hey folks, George Leoniak. I'm back with another video. This is going to be a how to draw video, and we're going to focus today on a different type of spiral. I know some of you have been checking out my videos. I've been pretty focused on the crystal spiral, but today we're going to actually do one called the silver spiral, which is one of the metallic spirals, meaning that most of us are probably most familiar with the golden spiral, the golden rectangle, and maybe the Fibonacci spiral. Those seem to be the most popular. Well, the next one down in that tier is called the silver spiral. There's also a bronze spiral and a number of other ones that are based on a simple mathematical equation. But I've checked out the some YouTube videos. There's very little information on the silver mean and silver spiral. So I decided to show you how to draw that with standard sacred geometry techniques. And we'll be doing that on the screen share here in just a minute. I just want to make sure if this is your first video with me, just review some of the tools of the trade. All you really need for this is your good straight edge, good compass, your mechanical pencil, and this drawing is going to be a little bit bigger than the other ones. You could do it at any scale. You could follow along at any scale, but I did this one on a much larger sheet because what I'm trying to do in this, based on the mathematics, is get this square in the middle to be 1 inch, which means we have to base these larger squares on the outside to another dimension of another measurement of 5.82. Now, I know that might throw you for a loop. So what I would recommend at some point in your drawings is to get like some calipers or something with some more precise increments on it, so you can measure out these in decimal or convert it to fractions. 5.82, 5.83, somewhere in that range is where we want to start if you're going to do it to scale. You could also base it on the original drawing that I did of the tesseract. So if you've already done the tesseract, you're going to see that this is going to be pretty familiar. It's going to be an octagon structure, and we're going to be building the spiral within that octagon because the silver spiral is connected to the octagon. So like I said, you could do this spiral right on starting off with the 2 inch rather than the 5.82 measurement. So anyway, that's just a little bit of overview of some of the materials you'll need. And now I just want to get into showing you the presentation and how to draw this. But first, let's just talk a little bit about the silver spiral. And you could find this little chart here right on Wikipedia under metallic means. And it shows you the numbers that are associated with each of the metallic means. Now, the number 1, where number equals 1 here, will give you the 1.618, which is phi, and that will give you the golden spiral here that we're most familiar with. The next one up here within this equation is 2 plus root 8 divided by 2 is going to give you 2.4142. Okay, so this one up here is 1 plus root 5 divided by 2. That's the standard equation that we see for phi all over the place if we're into this material. So that is going to give you essentially the golden rectangle to start with, and then you'll start building golden rectangles. Each of these are golden rectangles spreading out from there. But we're going to do one, it's this one, the silver spiral, which is the second one. So this one we've got 2 plus root 8 divided by 2. So now this is the second. If we did the third one, that would be the bronze mean, or the bronze spiral. And that would then, of course, radiate out with a different looking type of spiral than what we see here. So now the only 2 of the metallic means that have a associated polygon with it are the golden spiral and the silver spiral. Okay, So the bronze one doesn't have a number that someone's seen that will equate to a polygon shape. Now, what that means is that this polygon, if this edge here is 1, that means that this cross section of the star here is going to be the 1.618. And similarly here, if this is 1 for the edge, then this length going across here will be the 2.414. Now, just as an aside here, 2.414 is a number that may be jumping out at you if you're familiar with root 2. So if you went to your calculator and you hit 2 and you hit the little square root symbol, what you'll see is 1.414 and a string of numbers. If you're going to work with this on your own, all you have to do is hit root 2, square root it, and then add 1 to it, and then you'll have your value there right away. So the neat thing about this silver spiral, which I really liked as a design tool, was that it's going to fit right into the dimensions of the silver spiral. So there can be an octagon at each of these phases. For instance, there will be a larger octagon that we're going to construct around this, and you'll see that in the drawing. The phi-based one, the 5-pointed star pentagon here, that doesn't really correspond. Like, you can't really build this easily into the spiral at any place, whereas this silver spiral really fits nicely into each of these segments, as you'll see as we go on. So I put one other spiral on here just to introduce the Fibonacci spiral, because that one is often thrown back and forth in relationship to the golden spiral. And this one, this one's starting off the golden spiral right away with the Phi ratio. Each of these golden rectangles are going to be in Phi relationship. That means that this edge divided by this edge is going to be Phi, 1.618, each of these edges. Where this is starting with a square, number, equaling 1, another square, which is 1, and then you add on another because you add those two together, and this will be 2 by 2 box, and then you're going to add the 2 and the 1, and then you're going to get the 3 box, and then you're going to add those together, you'll get the 5 box over here. And then you're going to do these quarter circles throughout this to create that. The important thing to recognize, though, is that this right here, and what I've done is just from 1 to 5 in the sequence, is that it just is you're not going to be Phi at all. Like when you divide 5 by 3 here, it's not even going to be close to 1.618. It's not so much later in that spiraling progression where you start to get numbers that do start to approximate the golden mean number. So, okay, so then let's go on and I'll just show you how to draw. I know that was quite a bit of an intro there, but I want you to start to get a little sense of the spirals and how they're constructed based on this formula here. And so on your drawing pad, and I often recommend on these, is to kind of pause as you go so you can set up your equipment, do the line, and then go to the next step. So this is where you have to do that measurement of 5.82. So that's going to be your measurement. You could do it any length. You could follow these along and just draw what you want. But if you're trying to create the 1-inch circle, a 1-inch square in the middle of this, then this will be 5.82. And if you followed some of the other videos, we're going to now construct with your compass. You're going to set this compass needle here, and you're going to go to the far end of that line you drew, and then you're going to draw your first circle, and then you're going to go to the other side, set the needle on this end, set your compass edge up at this end, and now you've just drawn 5.82, larger than the diameter, double that. So like 11, I forget, 13.07 or something. You're gonna double those, and then you'll be able to have the Vesica Pisces in the middle, and you're gonna draw your line from the football shape through this line all the way down to here, and that will cross your original line. So now you could set your compass needle here, set your compass back up to the half the radius, half the distance of 5.82. So draw the circle, and now this circle will be the 5.82 circle. I know I went a little fast on that, but you know, all you want to do with that is make sure that that first line is 5.82 or 5.83, somewhere in that range, and draw that circle and use the Vesica to get the line in the middle to find the center point. All right, so the next phase is also familiar to the other drawings because remember, we're building this off of kind of that octagon structure. So now that your compass is set to that 5.82 diameter, which the radius is half of that, you're gonna set it up at the top of each of the corners, not the corners, the cardinal directions here of this circle. And you're gonna draw a circle so you create this flower petal design in the middle, just like a lot of the other drawings I've done so far, we've done this step. So we're going to do that, and that's going to give us the chance to draw the 45-degree lines that are going to go through the tips of the flower petals all the way through. And you might as well just extend out, you know, that other horizontal line if you'd like to. I don't think we need it for anything else, but you can if you want. All right, so we've set up our first 8 directions, and now we're going to have to do the same thing again. We're going to also draw in the 8 directions here. So now we're going to go and set our compass. The compass is already set to the half the distance of 5.82. We're going to go to the circle edge. We're going to draw another circle in each of the 4 corners. So we should have 8 circles here around 1 with 8 flower petals. And from that, that allows us to create a square off the first one. And rather than just be a square, what you're going to do is you're going to take your line and go all the way, you know, as far as you want. You know, you're going to make a nice tic-tac-toe board that's going to be fairly symmetrical all the way. So you're going to make that square, you can extend the lines all the way through. And then we're going to go to the side points, the 45-degree square, and we're going to do the square connecting these flower petal points of the other 4. We're going to run that all the way up and all the way up. So we got 4 new lines. So we just added 8 lines to the drawing. And now the key points that you want to focus on in your drawing are where those lines intersect, cross each other at the far end of the points here, all right? Because that's going to be the shape that you're going to need to work with. So just draw a little, you know, darker spot on each of those, just so you know where the crossing intersection is. Because that's going to be this points where you're going to draw in your octagon shape. Because remember, in order to draw this silver spiral, and we're doing this all by hand, you know, you can do it on the computer much quicker like this. But if you want to make a nice hand-drawn one, you want to get a real nice octagon set up with this internal structure of this 8-pointed star that you're going to see. So draw the octagon between those points. And then pretty much you don't need any of the other lines in there at this point, the red and the blue 8 directions, because now you're pretty much set to go. So now you've got your outer octagon, you've got your star. With this, we're going to now, at the inside, there's a smaller octagon that was created. Let's back up, because you should be looking at this right now. You've got a smaller octagon in here connected to the larger octagon here. So what we're going to want to do is draw another 8-pointed star that fits right in that octagon, like a holographic version of the larger one that we see here. And you'll notice that once we draw that line from up top back here, this will create the square that you need, the right size square to put one of the segments of the spiral in. And you're going to be creating that all the way around. All of these are going to look that. Essentially, we just did another 4D cube drawing, except we've drawn this line all the way across. So this is the silver spiral ratio is in this, whereas the silver spiral, what you have is you've got a 5.28 cube here, a 5.28 cube here, and then this distance in the middle between these two is the 2.14 measurement. And when you add that all together, this whole length will be 14.07. So that's the way the mathematics of this spiral are working out, or at least the design we've set up so far. So we're going to continue on again because we need to do another layer, another level of this. So in that other octagon shape, the other 8-pointed star you just did, you can have created another smaller octagon right in the middle of that. And at those same node points within this octagon, you're going to draw another smaller 8-pointed star right in there, another nested 8-pointed star. And we're going to do that one more time. I don't think we need this one just yet, but yeah, we'll move that off to the side. You get as small as you can. I know it's going to be difficult. This is why I recommended making it at the dimensions, the measurements that I discussed earlier, because it's going to get pretty small down in there to fit that last one in. For instance, this is the giant drawing I did, and I'm way down in there at that step now in there. I'll show you this at the end, see what it looks like again. But if you're doing it on something like just like a sheet of paper, to get these last little ones in there is going to be tight, quite a tight area. So at this point, you should have 4 nested, or 3 to 4 nested 8-pointed stars within these octagons. So, now we've, the next step is we've done all the preparation and setup. Essentially, we just created the tesseract, the 4D cube, but we're going to take that one step forward because we're going to do the silver spiral, which, I thought was pretty cool to see that the silver spiral automatically fits into that 4D design. The dimensions are the same in the octagon shape. So where you'll set up your first square. Now, these are just quarter circles. This is going to be down at this corner, and you're going to set your compass over here, and then you're just going to raise the arc up till it meets the opposite corner over here. And that's your first arc of the silver spiral. And now you'll see why we set up all these other lines because of the other stars, because they give you the inner edge of that square. So we're going to set up over here, we're going to go across, and then we're going to arc up, we're setting up over here with the needle point, setting up the edge of the lead over here, and drawing it up till it connects to that point. So now we've got 2 arcs of the spiral. Third one, now this is in the 1-inch square right now. So that's the 1-inch square. This is the 2.41-inch square, and this is the 5.28-inch square. So we just arc that all the way around. See, we're making the nice curve. They'll have these little quarter circles. And on my drawing here, I'm able to fit one last one in here, and that's at 0.82 for that last little one. It's going to go right into the center point. And you had to draw one line there to kind of fit it in there. One more cross section of the next 8-pointed star. But at that point, it might be too tight to get in the rest of the 8-pointed star in that section. So all that work to get these 4 arcs of the silver spiral. But as a design tool, it's quite, like I said, it's easier to do on this PowerPoint that I'm showing you just with this, but easy to set up. If you want to do it by hand, these are the steps that I have come up with, since I haven't seen anybody really show a good accurate way of doing this yet. So here's a video that does it. So I just removed the 4 squares that are reduced in size all the way around. to create the silver spiral. And you often see this depicted this way. And this is what I thought was quite cool about this design, is that you can do the opposite opposing spiral coming out of the center area like this. Now you have to keep going, smaller and smaller and smaller before these will appear to be in the center. You can kind of tie that off in there eventually if you want, but it's cool to create that, especially within the octagon shape, reminiscent a little bit of the Taoist symbols, which is often just a circle with two half circles like this. But putting the octagon shape in a crystal spiral, which has different mathematics associated that just fit the octagon, is quite cool. So that is essentially just this shape. Here is the ratio that we're looking at. If each of these are 1 inch, 1 inch, add those two together. So you have 2 plus this little space in the middle is the 0.41. So that's the 2.414 measurement. And that will give you that length. And then you rotate this whole shape, and then that gives you 1 inch in the middle. And then that gives you 2.41 inch on this side, 2.41 inch on that side. And then that will give you the whole length of this width of the next giant rectangle, which is, once again, is 5.28, 5.28 on this side with the 2.41 in the middle, which gives you the whole length of the 14.07 of the whole thing. And then, of course, you could see where we're going with this. You take the 14.07 and then you're up and off the screen. But this is enough to get the general notion across, because my paper, this is quite a large sheet of paper already, and I'm pretty much stretching the limits of what I can do on there. So it didn't take too long. If you follow those steps and you want to not just have the silver spiral, you can get more creative with this and create a nice spiral design here out of a silver spiral by just doing each of the octagon edges. So you can have 8 spirals going this way across these lengths. Here's the 2 that are connected here and here, here and there, here and there, and here and there. So you can create that. You could erase all the octagon lines and just be left with the spiral if you want. I'll show you some of that in a sec. But you can also then counter rotate that one and then put both of those together. And I find it a real easy way to kind of create that spiraling pattern, because it fits in the octagon and it goes right towards the center, which is way different than working with the golden mean spiral, which, in order to make these counter-rotating spirals overlapping one another is quite difficult in that design, because you have to reset the whole rectangles over and over and over again, where this is just all contained in the octagon. So I can see the beauty and ease of this system, creating this spiral, which is essentially built off of the same mathematical formula of the golden mean spiral, except the only difference is instead of having 1 as the number, you just started off with 2, the second one in line. And then it fits in this, the only other polygon shape, the octagon, that those metallic means match up with. Although I might have found another, which will be coming in a video down the line. So now we've got this set up like this, and it's nice if you have a light table, you don't have to keep redrawing everything from the beginning. You can erase things, or you can just do them like I'm showing you here. There is something about doing the hand drawn, but there is something ease about just removing a layer, and all of a sudden now you're left with this 16 spirals here going all the way around the red and the blue, all the way, both directions, as a kind of neat, it's almost, to me, reminiscent of like a dream catcher kind of design. It really has that effect to it. I like this spiral too, in construction wise, because it has some similarities of going towards a center point, which we can build the other spirals off of quite easy. It's more comparable to the crystal spiral video that I just did. That one's mostly built on the counter rotating squares, which also is similar to the spiral coming out of the center, and this one is built within the octagon structure in that larger rectangle. So, okay, I wasn't going to do this, but I'll do one last bit, a little bonus material, because I don't think I'll do another video on it. If you're done with this spiral section, the silver spiral, that's great. Hopefully that helped you out with figuring that design out. But I wanted to show you one last piece of, you can create basically a full circle design if you go to the anchor points to create that half arc, quarter of an arc of one of the spiral segments. If you went ahead and just made that a full circle, you would actually be creating the segment two squares, 3 squares away on the opposite side of it that share the corner. That other arc would land over here, and that one is over here. And if you just went and did the full circle around, it would come out here. So, the neat thing about that is that just it allows for your own new design space to just go to those anchor points and just do full circles all the way around, and you'll create that inner spiral that I showed you back here. You're going to be creating that because you're hooking up with this one, and at the same time you're creating the arc that's over here. So it's just, all it really is just a full circle going all the way around. And when you remove all the lines on that, then what you have is these 8 circles that are overlapping in this neat looking pattern. And if you wanted to get creative, I did a drawing like this. I'll show you at the end here on the full sheet of paper. But it was easier to construct just digitally here. I successively created the smaller arcs. Actually, I didn't do that one. I just did the larger ones because I didn't do these smaller ones in here. But then I did, for the next octagon in, I did those 8 circles. And the next octagon in, I did those 8 circles. And then the smallest ones in the middle. And then I rotated the whole thing 45 degrees just to create the star pattern, 8-pointed star like this. Just showing and emphasizing that holographic view of the pattern expanding out from the center containing those circles. So I know that was another quick video. I probably talked a lot faster than I was hoping, but I hope it got most of the material across. This was the design I was discussing of adding the full circle all the way around. I didn't do them at the further end level because it might have got a little more confusing, but these now kind of create a frame on the outside of the whole drawing. So yeah, pretty neat design. It's cool, like I said, connecting to the octagon, and I'm hoping that maybe it will inspire some more folks to get into, giving the silver spiral a little more love out there next to its golden cousin. And maybe this design, especially as it relates to the 4D hypercube, just that it overlaps so nicely. I just find it as a really appealing silver spiral design. So yeah, let me know if you found the drawing techniques, if you were following along, useful and helpful. I'm always open to suggestions or tips that might help you more. But until then, happy drawing, and I hope you're getting into the subject of sacred geometry, and I'm thankful to be able to share my passion and interest with you. So much love, and thanks for watching, and I'll talk to you next time with another drawing or video related to sacred geometry. All right, talk to you later. Bye.